So let's do this right now. What I would like you to do is to fill out this chart for me as I go along, because we haven't much time. Now here's the it's 1 minus. Now let's plug in 0. What is e to the 0 power? 1. What is 1 minus 1? 0. 0 times the 200 is 0. So this starts at 0. Did you get that? Okay, now we're going to go to 2 seconds. What is e to the negative 2 divided by 2? What is 2 seconds divided by 2 seconds? Negative 1. So this is going to be, let me turn my calculator on. One minus e to the negative 1. And that gives you 0.6321. Then we're going to multiply that times 200. And we get 126.4. So look, we went from 0 to 126.4. Now let's do 4 seconds. What is e to the 4 divided by 2? It's e to the negative 2. So 1 minus e to the negative 2 times 200. 172.9. Let's do 6. Plug in 6. 6 seconds divided by 2 seconds is 3. So this is negative 3. So 1 minus e to the negative 3 equals 0.95 times 200, 190. What are we getting closer and closer to? To 200. Plug in t equals 8. Negative 8 seconds divided by 2 seconds is negative. What is 8 divided by 2? 4. Negative 4. Is it negative 4 seconds? No! Those seconds have been canceled out. So 1 minus e to the negative 4 equals, oh my gosh, 0.981. We're getting closer and closer to 1. And then times 200, 196.3. Now, last one. T equals 10 seconds. 10 divided by 2 is 5, negative 5. So it's going to be 1 minus e to the negative 5 equals 0.993 times 200 equals 199 if we round it off. Or 198.6, but I'll just round it off. Okay, so let's graph this really quick. And actually, you know what I'm going to do? I'm going to take a shortcut. Because I've already graphed this, the time and temperature scale. I did it right here, didn't I? But now, at 0, we're starting at 0. So I'm going to put them on the same graph. At 2 seconds, it's 126.4. So 126.4 would be right there. Is that right? 120, right there. Now at 4 seconds, it's 172. 172. At 6 seconds, it's 190. At 8 seconds, it's 196. And then at 10 seconds, what are we at? 199. Almost exactly 200. What are we never going to get to? We're never going to get to 200 because this will never equal 1. It'll always be slightly less than 1. Okay, now let's fill this thing out. So this graph right here is 200 Kelvin times e to the negative t over 2 seconds. But this graph is 200 kelvins times 1 minus e to the negative t over 2 seconds. And you can see that they're kind of a mirror image of each other, huh? You take one graph, you flip it, you get the other one. Yeah, that's not a coincidence. This graph approaches 0 but never reaches it. This graph starts at 0 and approaches 200 Kelvin but never reaches it. And there's some other properties of these graphs that are really, really cool. And we're going to be using a lot of them. So here is your homework. Sorry it's homework because so much class time got used up today by other stuff. But I'm going to pass this out in a minute. Now look at this. Q, that stands for heat, equals 100 joules. So this is going to be 100 joules, 100 joules. But this one is e to the negative t over 4 seconds. So what's my time constant? This is my time constant, 4 seconds. So you're going to go in multiples of 4 all the way out to 20 seconds, 0 to 20 seconds. Look at this. This one is temperature. Now, by the way, on the ones you're going to get, there's a little misprint on it. Sorry about that. So I'll tell you what, on these, you can graph the two functions on the same graph, just like we did the example. Okay? And this will get you started graphing exponential functions. And they're really, really important, very cool, and you're going to see why later on. That is all.